All right, fourth graders, we're back here for some more fraction work. So let's go ahead and get started. So today we're going to be talking about two things. The first thing we're going to be talking about is fractions that equal 1. And the second thing we're going to talk about is we're going to talk about comparing unit fractions. So kind of 2 for 1 in this lesson. So let's start with fractions that equal 1. Well, let's say that I have a piece of pizza, or rather a whole pizza, and my pizza is split into 5 sections. How could I write? So I know that writing just one of these, right, would be 1/5. But how could I represent the whole pizza? Well, 1, 2, 3, 4, 5, right? 5/5. 5/5 would equal the whole pizza, right? Because I'd get 1, 2, 3, 4, 5 pieces, which is the numerator, out of 5 pieces that the whole is split into, which is the denominator. So I could say the whole pizza is 5/5. What if my pizza was split into 8, though? 1, 2, 3, 4. I've got 8 pieces. I'd know that just one of these would be 1/8. So how many eighths would I need for the whole pizza? Well, I need 1, 2, 3, 4, 5, 6, 7, 8. 8 eighths. Now you might be noticing a pattern, which is that in both of these wholes, the numerator is equal to the denominator, right? So any fraction where the numerator and the denominator are the same number are fractions that equal 1. So 5/5 equals 1, 8 eighths equals 1, 10 tenths equals 1. What's another one that equals 1? 17 seventeenths equals 1. 999 999ths equals 1. Any fraction where the numerator and the denominator are the same number is equal to 1 whole, right? And you saw that in the pizzas. How is this helpful? Well, let's say I have the problem 1/7 plus what is equal to 1? So I've got a missing number. What should I add to 1/7 to get me to 1 whole? The way I like to solve this problem is by saying 1/7 plus blank and changing 1 into a fraction that's a little easier to work with. Remember, any fraction where the numerator and the denominator are the same is equal to 1. So instead of writing 1 here, I'm actually going to put it in terms of the same denominator. So it's something sevenths. Well, and I remember that any fraction equal to 1 has the same numerator and denominator. So I can say 1/7 plus something equals 7/7. Well, I know that 1 plus 6 is 7. So it must be true that 1/7 plus 6/7 is equal to 7/7. So I figured out that problem. Let's try another one really quickly before we move on. Your turn. 2/6 plus something is equal to 1. How could I find that missing number? Well, I know that 1 doesn't really help me in this case. So let's change 1 into a fraction. I could write 1 as something 6. It's got to be 6/6, right? So I've got 2/6 plus something equals 6/6. And then it's easy for me to figure out, well, I've got to add 4 more 6 to get to the full 6/6. So just something to be aware of is that when you see a fraction where the numerator and the denominator are the same, it equals 1. And you can use it to help you figure out how many more pieces you'll need. For example, if I visualize this one, I'm not really that good at drawing sixths, but I'll try it. That's not bad. Okay, there's 6 pieces there. It's not bad. If I've got 2/6, the question really is, how many more do I need? 1, 2, 3, 4. Got 4 more 6s. All right, so that's kind of part 1 of this lesson. Let's go ahead and move on to comparing unit fractions. I'm going to erase this. Comparing unit fractions. Here we go. All right, let's say I have the numbers 1/4 or 1/4 and 1/3, and I want to compare them. Someone asked me which one's bigger. Now we've done some comparing before, like let's say you have the numbers 17 and 23 and somebody asked which one's bigger. You probably did this in like first grade, right? And you said, oh, this one's bigger. The alligator eats it over there, right? 23 is bigger. Same idea here, but this time with fractions. So what's bigger, 1/4 or 1/3? Let's try drawing a length model. I like length models. Let's do this. So let's split it into quarters. Let's draw out 1/4 to see how big it is. And then let's draw out 1/3 to see how it compares. Got to make them the same length, otherwise it does not work because it's got to be comparing the same size whole. Doesn't have to be perfect, but close enough. I can clearly see 1/3 is going to be bigger than 1/4. Now you might take a look at that and be like, wait a second, 3 is smaller than 4. How in the world is 1/3 bigger than 1/4? Let's think about it this way. Let's say you're sharing a pizza we've got our pizza. And would I rather have a group of 4 people or a group of 3 people when I'm sharing? If I've got a group of 3 people, I get this big old chunk, right? Nice. But if I got a group of 4 people, I only get a quarter, which definitely is smaller than that big chunk, right? So you think about it this way: when the numerator is smaller, when the whole is split into fewer pieces, your piece is actually bigger. That one of those pieces is actually bigger. So when you're comparing unit fractions, the number with the smaller denominator is actually bigger. It seems kind of opposite from how it should be. But when you think about it with pizza like that, it kind of starts to make sense, right? So again, when you're comparing unit fractions, the number with the smaller denominator is bigger. Now, this only works with unit fractions, so don't try this on other fractions unless you know what you're doing. Try one more. Let's do 1/6 compared to 1/8. Okay. What should I do? Let's remember our rule. When you're comparing unit fractions, the number with the smaller denominator actually is split into bigger pieces, right? So 6 is smaller than 8. So 1/6 must be bigger than 1/8, right? You'd rather share that pizza with a group of 6 than with a group of 8, because then you get a little tiny piece and then you're not full. So that's comparing unit fractions. You can use that to compare. You can use it to put them in order from least to greatest. It's a really good little trick to know how to do, is comparing unit fractions.